Hi, I'm Lisa White. I'm Assistant Director of the University of California Museum of Paleontology, and I'm here with colleagues and friends, Wayne Thompson, a local geologist and middle school teacher, and Chuck Powell, scientist emeritus from the U.S. Geological Survey. And there are a series of questions that I'm asking them about their work and their research here at the Parisima Formation in Santa Cruz County. Wayne, what do you enjoy most about being a paleontologist?
I like the excitement of discovery, of uncovering a fossil that nobody else has seen before, of not knowing. It's kind of like Christmas. You're opening a package and you don't know what's in there. Is it going to be something exciting? Is it going to add to the research? So it's really exciting in that way, and to learn more about the natural environment.
When did you know you wanted to become a paleontologist, and what was your career training?
I probably decided to be a paleontologist fairly early on. My dad and his dad built an amusement park here in Santa Cruz called the Lost World with animatronic dinosaurs that were life-size. And so I grew up from the age of 2 in this kind of crazy world of dinosaurs out in a natural setting, and it was just fantastic. And then when I was 16, back in 1976, my mom brought me down here because she knew I was interested in fossils, and it was a great place to learn it, and it still is a great place to learn and discover.
And what's unique about the Parisima Formation here at Capitola Beach? And have there been some fossil finds over the years that have surprised you?
Absolutely. The Parisima here at Capitola Beach is really an unprecedented record of at this spot, Monterey Bay, in history. And it's recorded the changes that have happened here, the creatures that have lived, the ecology really of this region over time. And it's super exciting to be involved in studying that and digging it up, so to speak. The different finds over the years, they're still being discovered. We discovered a new species in that block right there 3 weeks ago,
Nice.
a trochid snail. And as far as we know so far, it's new to science. So new discoveries are happening all the time, and there's been some creatures that have lived here that don't live here anymore. We have a whole suite of different types of walruses that are recorded in these cliffs, other vertebrates, pinnipeds, seals, and sea lions, various types of whales, and things that you would normally think of in the marine environment. Some very different from today, some very similar. So, over the years, things have been discovered that really enlighten our view of this area.
Great. And how have your collaborations with other scientists helped to inform our understanding of the local geology and paleontology?
Absolutely. Science doesn't happen in a vacuum, and we rely on the expertise of many different scientists, from sedimentologists, geologists, vertebrate paleontologists, invertebrate paleontologists, ichnologists, who are people that spend their careers studying traces of creatures that have lived in the past, like burrows and footprints, things like that really help us get a great general understanding of what was going on in this area, 3-4 million years ago.
Mm-hmm. Wonderful. And how can educators best use the Capitola Beach section here to teach science, earth science in particular?
Yes. It's a great environment for bringing students out to learn. The different strata that are recorded here have lessons to teach them on the ecology, the changing ecology that's recorded in these cliffs that has happened, over the millions of years, from deeper out in the ocean to changing environments, the ocean receding, and the ocean sea level getting higher, and the different climatic cyclic changes that have been recorded in the sediments, and as well as the creatures that live here. So
Great.
Yeah.
So Wayne, what's going on in the cliff here, and why do we see so many large boulders on the beach?
Well, there's a natural process of cliff erosion that goes along with any beach environment. Some places are sloughing off more than others, and for our work here, these rock falls allow us to really get a window into what's going on in the cliffs. So by looking at the rocks that fall around us, we can really get a handle on the different strata and who lives there. And
Great. It's also a reminder just how careful we need to be, right?
Absolutely, yes. We typically don't get any closer to the cliffs than here. And when we bring students out, we always be sure to stay far away from the cliffs because they are actively eroding. At the same time, these erosional spots, the rock falls, really allow us to do our work of looking at what is coming out of the strata.
Great. And then what are some things that we see here on the beach?
We're seeing quite a bit of shell deposits in this hard rock here. All these hard rocks are probably from the same layer, way up the top of the cliff here, and because they're cemented together, they don't erode on the beach. And then the majority of the rock here is softer, like this piece right here. But all of the rocks here that you see are cemented together very strongly.
Okay. And there are a fair number of vertebrate bones, right, in the Parissima here?
Yes, there's over 50 different species of vertebrates here. There's cetaceans, pinnipeds, birds. We have some very interesting suite of cetaceans that are from here, and really give us a good picture of what was going on here in Monterey Bay 4 million years ago.
Right.
We can actually take a look at some of those too.
Yep. Great. So I'll follow you. Let's walk around and look at a few beds. So we talked about some of the bone beds here in the Parissima Formation. What are we seeing here?
This is sand that's from the bottom of the ocean about 3 to 4 million years ago that has been solidified into sandstone. These are bones, probably from a baleen whale here, the lighter parts. These holes here and here are from bone-eating worms that feasted on this whale before it was buried and fossilized.
Wow.
These black pebbles right here are called phosphate nodules, and they have environmental things that they indicate. This is another piece of the bone that's a little darker here. Oftentimes in this particular layer there's what are called steinkerns, which are the molds of clams and snails preserved in this layer. And actually this layer here, if one looked at it close up, there's actually 4 individual layers within this layer. So looking at it very closely and studying it, we can find out that it has a real history to share about how whales get preserved in the fossil record.
Okay. And the depth of environment for the Perissima, back in the Pliocene, would have been similar to what we see in Monterey Bay today. So, shelf and slope.
There's most of the Purisma is near shore. And Chuck could correct me on this if I'm wrong. Most of it's pretty near shore. There's channel deposits. There's storm deposits. There are various types of accumulations that represent different environmental regimes. And that's the beauty of this, is that you can come to one spot and you can see a diversity of different types of oceanographic and ecological processes that are recorded in the rock. And for students, that's just a fantastic teaching tool to be able to have right here, one-stop shop, and you got it all. It's great.